Hi, wonderful physics students, and welcome back to Physics with Captain Rod. I'm making this one to help you out with number 5 in your Unit 3 homework. So let's get started here. Number 5 is about Timmy and his toy cannon. Now really it's all about the toy cannon here. And this cannon, let's see, is 500 kilograms given here. It fires a 25 kilogram cannonball at 900 meters per second. And let's see, what are we going to try to do here? Find the recoil speed of the cannon and the average force that stopped that cannon from rolling. Now, the stopping it from rolling is referring to this. Timmy observes that when the cannon goes off, that the cannon rolls backwards 5 meters before starting. So the first part of this problem is kind of analyzing what's happening between the cannon and the cannonball. And start by writing this out, right? Remember momentum methods. Mass times v initial, right? That's the initial momentum of a system, plus the impulse, F delta t, acting on the system equals mv final, the new momentum of a system. And what we're going to want to do is this. Define your system as the cannon and ball together. Because as long as we consider the cannon and the cannonball together, there's no external forces acting on that system. So basically, we won't need to worry about this. Draw a picture of the cannon and the cannonball for the initial momentum. Basically, just clone this. Then draw a picture for the cannon and the cannonball for the final momentum. So draw another picture of the cannon and the cannonball. Now keep in mind, in your second picture, the cannonball is now moving to the right at 900 meters per second. Draw it, like right at the end of the barrel and moving. And put a momentum vector on it. And if you want, you can calculate a number for that vector. Rather than putting mv2 or mv final, you can just get a number, right, from these two things. Now you can imagine what's going to happen. That cannon is going to be rolling, it's going to be recoiling to the left. So in your picture, put a momentum vector on there for that and label it mv, where the m is going to be the mass of the cannon and the v is going to be the unknown cannon velocity. Now, once you get your pictures right, then you can write your momentum equation, right? Basically, you're going to write this out. Before the cannon is fired, there is no momentum. That should, nothing's moving yet. That should tell you what this is. The only forces acting are internal forces. There's no external force changing the momentum of the system. That should tell you what that is. And then the mv final. Now think of this conceptually, that stands for the final momentum of the system. In this case, the system, though, is the ball and the cannon. The ball should have, it's moving to the right, so it's got a momentum to the right. The cannon has a momentum to the left. So the net momentum is going to look something like the momentum of the ball. Now I'm going to say plus the momentum of the cannon. Now I'm going to say plus, but remember, these are vector quantities. So you have to decide, is it going to be minus something or plus something? I'll let you think about that. You should end up with a very short, fairly easy equation here. You should be able to solve for the velocity of the cannon. I called it velocity cannon picture 2. I got 45 meters per second. The arrow here means to the left. All right, now to do the rest of the problem. Timmy observes that that cannon rolls backwards, about 5 meters. So this is a distance. When you're given distances, you want to be thinking about terms of work and energy. So write out the work energy theorem for the cannon only. So write out the PE1 plus KE1 plus work equals PE2 plus KE2. And take note that the cannon, it's not moving up or down. It's a constant height problem. There's no potential energies to worry about, so we'll just throw those out. The KE, to tell you the truth, let me talk numbers here. If we call position 1 before firing, 2 just after fired, so the ball's moving this way, the cannon's rebounding, I would say that position 3, the cannon's over here, it's not moving anymore. So when you write out that work energy theorem, I would write it PE2 plus KE2 plus work equals PE3 plus KE3. So again, 1 is before the ball is fired. 2 is the instant the ball leaves the barrel. So the ball's moving to the right, cannon's moving to the left. 3 is after the cannon has rolled to a stop. There are no potential energies to worry about. Position 3, the cannon has stopped. That should tell you something about this. Right. Now the work term. Work is force times distance. Think about the force direction acting on the cannon. Now, right when the cannon is fired, it's rolling backwards to the left. Later on, it's stopped. So ask yourself, what is the force direction acting on the cannon? Then decide whether the work term, this should be like plus force times distance or minus force times distance. Keep it in mind, the cannon is rolling to the left. So anyway, put this stuff together. That should allow you to solve for this force. I got 101,000 newtons. My arrow here means to the right, acting on the cannon. So anyway, that should hopefully get you through this problem. I hope that you're enjoying these momentum problems. Have a great day.